Okay, so here's an example of templated workflow. It's super simple. Turning one. You use the container method, so you've got components that act as containers for model, in this case fixtures or chuck, and then you can also have one for stock. Now the model component container is empty, other than the fact that it's got a joint origin there as a suggested place to attach the part you're going to insert to get clearance off your chuck jaws. And in the manufacturing workspace, there's a setup that's pre-created. You can see the stock is super small at the moment, and there's a bunch of toolpaths in there waiting for a model. So everything's kind of pre-selected based on the containers. So here we've selected the model component, but there's nothing in there yet. From solid and then fixtures, so whatever ends up getting put inside the fixtures component gets added to the from solid selection, and then you could do the same thing with stock if you wanted to, but in this case we're using relative size. So if we come back to design and activate the model component and then insert a turned component, that could be modeled in any CAD system and then imported using just imported or referenced using any CAD. Now if it ended up in a position out in space, that's fine, because you just then use a joint to place or join the part onto that joint origin and then activate the top level component. Then we come into manufacture and right click on the setup and generate our toolpaths. Now the facing is done. I've also got in the analysis folder here an XZ section already created, so my facing is done, profile ruffling is done, OD grooving has needs some selections, so when we edit that we'll see that there's some missing references. Yep, I may as well clear them. And if I right click I can see that I need to provide a front reference for the groove and a back reference for the groove. Okay, and the toolpath's generated. We only have one groove on this particular part, so we can either delete or suppress that one. That then releases the in process stock to calculate for the subsequent toolpaths, and then it's stopped again because we've got some ID grooving here, which rather than using selections for containment is using rest machining. So because the in-process stock has changed, that's invalidated. We need to regenerate. That then frees that up to generate. ID threading, just need to pick the face. Now, ideally with ID threading you just have a whole series of turned threading templates based on the thread designation, and then you apply the appropriate one for whatever the specification is of that particular bore. And then parting with chamfer has found the back of the part and cut the part off. So if we simulate this now with stock turned on, you can see that we'll turn the toolpaths off, and we'll speed this up a bit. It's all ready to go and everything's done and validated. Then we can right click on our NC program and post process and generate our code, and that's it. One step I missed is in that process is I need to save as and save it out as whatever the job is. Now it's the same process for milling as well, and I'll just open up an example here. I'll do this one here. Actually, yeah, I'll do this one here. I won't bother going through and putting the part in, but in manufacture we've got a 4-axis setup and a 3 or 5-axis setup, and the 3 to 5-axis setup is already pre-toolpathed with a whole bunch of adaptive toolpaths and flats, and you can the more of the 3D toolpaths you use, then the more dependent they are on the model. But increasingly with 2D toolpaths, so like 2D adaptive clearing, you can do pocket recognition, and then with holes you can find holes based on boring, find them based on diameter range along the tool axis, and so on and so forth. But you can just see this is a bit more fleshed out. We've got stock here that's pre-modelled, the model container itself, the vice assembly, and then containment geometry. So if you, in this case here, the pedestal for tab machining workflows. And I've left this kind of unconstrained, so that once I've got the component in place, I can just eyeball the how big of a tab that we need, and then use parameters to change the stock size and length and so on and so forth to suit whatever part we've put in there. The idea with this, this would actually be called fixtures again, and I can just remove these jaws out, and there's no actual selections based on those jaws, so there's no failures that occur as a result of removing them. So just built up using resilient parametric modelling methodologies, and so yeah, nice and robust for lots of different types of users to pick up and use once the process has been documented.